Hello, this will be a video on the liver model that we have in lab. Here's an anterior view of it. Here's that same view of the liver in our torso model. You can see the liver is just inferior to the diaphragm on the right side of the abdominal cavity. So let's go back to our model. Just on this view, what we can see is that this is a multi-lobed organ. It has the falciform ligament here. Here's the two folds of it. So you can imagine some parietal peritoneum, that serous membrane, coming off of it on either side and attaching to the anterior body wall. Also, you're seeing a fold of the parietal peritoneum come across over here and come across over here. And that's some parietal peritoneum coming up and attaching to the superior part of the body wall. And we call this the coronary ligament right here, okay? Coronary ligament. That's when you were, we did the demo, you were trying to put your fingers in there and you were touching the parietal peritoneum coming off of that right there. And then the falciform ligament, you guys are familiar with that. That's attaching, it also has the remnant of the umbilical vein in there, ligamentum teres, and then we'll see that on the other side. So now let's look at the model from the other side, on like an inferior posterior view of it, where the artist decided to open up the lobes of the liver so you can see all the different vessels and ducts that are inside the liver. You're also seeing that ligamentum teres right here run all the way to the inferior vena cava. This used to be, when you were a fetus, the umbilical vein where all the blood from your mother was traveling through. And that's also deep to this. You're going to find the falciform ligament that's attached to it, if you can remember from our demo in the cadaver room. So this is the latter part. This is when the latter part of the hepatic portal system enters the liver. So this purple part right here is the hepatic portal vein. It is entering the liver. It's where all of the blood that came from the spleen, the intestines, the stomach, the pancreas, traveling through the mesocolon and the mesentery, have made its way, converged into this vein and made its way into the liver. Then that blood, which is actually only partially deoxygenated and actually glucose rich, has some electrolytes in it, and it will make its way to the liver and then actually allow for some of that oxygen to diffuse out and reach the liver cells called hepatocytes. It also, the glucose, the excess glucose and electrolytes will be stored within the liver. So the blood that goes into the liver, you could say, is glucose rich, oxygen richer than the blood that's going to leave the liver eventually through when it reaches the inferior vena cava. So all that blood's coming in to the hepatic portal vein, and then it's going to branch out. The hepatic portal vein will start to branch and branch and branch and branch, turn into venules and then capillaries. The oxygen will diffuse out, glucose will diffuse out and be stored. Then it will turn back into venules and then into veins, and that's what we're seeing in the blue here. So this is like they're now turning into venules and then veins and making their way to a hepatic vein. So they're eventually going to converge into these hepatic veins over here and then attach to the inferior vena cava. Now this blood that's entering the inferior vena cava is glucose poorer and oxygen poor. And then that will make its way to the right atrium of the heart. What else are we seeing? We're also seeing just next to the hepatic portal vein is the hepatic artery, common hepatic artery. That's going to supply a lot of oxygenated blood to the liver cells as well. And you can see that starting to branch out into arterioles and then to capillaries. What else can we see? I think that's about it. Yeah, and here's another view. We didn't really look at this side too much. But there's the inferior vena cava running through that sulcus right there. Okay.